These are panes of glass from picture frames. Now, I couldn't use these frames as they are for this experiment because they have to be taped. I'm going to show you what I'm talking about. You take a fiber-back tape and run it along one side of the glass, around all four sides like this. So I've got tape here, no tape here. And I do that with both pieces of glass. And I usually try to get a smaller piece for the top piece. Here you can see the tape around each side, and I've fashioned a little handle. Now, what I want to do in this experiment is I want to press the glass panes firmly together, and then I want to lift the top glass pane, and hopefully the bottom pane will come along with it. So we lift the top pane, and guess what? The bottom pane didn't come up. Well, I guess I have to add something to this experiment. So I'm going to take some of my colored water from a previous experiment and spread it over the top of the bottom pane. That should just about do it. Now I will press the top pane firmly, but not firmly enough to break the glass, because if you break the glass, you can't really conduct this experiment. Now let's try it again. I'm going to try to lift the bottom pane of glass up with the top piece of glass. Watch my left hand as I do this. As the glass comes free of the paper, I slide my left hand under there. That's in case Mother Nature plays a trick on me and decides to drop the bottom piece of glass. That's also why I put this tape on here. In the event that an accident occurs, the glass won't shatter. Okay, what is the science behind this particular experiment? Depending upon who you consult with, and I always consult with a scientist when I'm getting one of these demonstrations ready, meteorologists and the like will say that the 14.6 pounds per square inch of air pressure is strong enough to support the glass as you raise it up. Chemists and biologists will say no. What lifts the glass is the surface tension of the water. Now, what do I mean by surface tension? We all know that water is made up of molecules of hydrogen and oxygen. Well, it just so happens that the molecules of hydrogen like one another. They become attracted to one another. It's called hydrogen bonding in scientific terms. In layman's terms, it's probably called surface tension. So these hydrogen molecules have bonded together, and they've created what I guess you'd call a thin glue between the two pieces of glass, and that allows me to bring them both free of the tabletop. To illustrate that a little bit further, I'm going to put a drop of water on the end of my finger there, and you can see it hanging there. It's hanging there because of the hydrogen bonding. And the hydrogen bonding has, well, it's formed a skin on the water. That drop of water will hang there until the skin breaks because of the weight of the water, or until the water evaporates. So this is an interesting demonstration. You're getting into a little bit of chemistry here. Hydrogen bonding.